Good afternoon, boys and girls. How are we on this fine evening?
You're not the professor, Zach. What are you doing?
Excuse me, sir. I don't appreciate that kind of language.
Get off the stage.
Cloud City's great, man. Boo you, man.
Get off the stage.
Actually, not while I got you, bro. What's up with me ordering Chipotle through DoorDash and me getting half the servings that I normally get when I walk into my restaurant that I allow you to work at, bro?
Look, I don't care because I don't work at Chipotle anymore. Hey, yo.
Oh, did you quit?
Yeah. Actually, yes. Sunday was my last day. I got an internship.
Oh, hot. Where?
We make big screws or something.
So it's not IT?
No, I mean, I work IT for this company that makes big screws. Like, I don't know anything that we do, but
cool, big brain. I don't know how NIPSCO gives gas out, so that's fine. Actually, no, I do. They dragged me to their like safety village, and I learned how to like steal gas.
Don't you know there's a Dr. Pepper shortage going on?
I
know where I'm going.
What
Look,
shortage, bro?
Look, it's Pib.
It's Pib or nothing.
It's Pib or nothing.
Jacob, get out of here.
Hello, everyone.
Hey, my main man, Dr. Calix. How's it going?
Hello, how are you? Welcome
Real
to
professor.
ITS 450. I've had so many problems with Zoom today, and you guys were easy to admit into this, but so I'm glad about that. Okay, so welcome back. Unfortunately, we're still doing this online thing. So anyway, well, at least we've had the experience last semester, so we kind of know how it works at this point, which is good. So, you know, today I'm going to introduce the description of the course. You know, this is ITS 450, so I will go over you know, all the materials, everything, and then we'll just get kind of started with motivating the course. What is this about? You know, this is software assurance, so you know, we'll kind of talk about that. And then, as you know, this is a lab-focused course, and so we'll start talking about the labs. Okay. So, are there any questions before I get started?
Nope.
No questions, all right? And just give me a minute. I have to take a picture of everyone that's in the class. All right. So just as you know, the first 2 or 3 weeks, I have to do roll call so we can update the course participation in the system. I think that has to do with your financial aid and things like that. All right, so let's get started then. So a lot of new things this semester. We have not Blackboard anymore, but Brightspace. And so we'll talk a little bit about that. Let's get started. Okay. So let me share. Remember, just like I did last semester, we're doing live synchronous sessions, but I'm also recording these videos. Okay, so remember that I'm recording the videos and I will be posting them on YouTube and then linking them on the calendar as I did last semester so that you guys can reference things, or if you miss class for whatever reason, you can look at the material. Okay, so I'm going to go ahead and share. I'm going to share the Brightspace here. Okay. All right, so basically Brightspace, the way that I'm using it, I have two sections. One is the course home. where you will hopefully see all announcements. Here I have the announcement of the Zoom instructions, as you can see there. And then there was the original announcement just welcoming you to ITS 450. And then a few important links and information. So assignments will be just like with Blackboard, you're going to submit your assignments on Brightspace now, but it's gonna be basically the same approach that we've used in the past. As far as VMs, in this course, we really just need the seed VM, or this is really for a lot of you probably one of your last classes. So it's basically just continuing with the seed labs. So if you don't have the VMs, or for whatever reason you forgot, remember you can always go to this website. I know we don't have the torrents right now, so this is probably the best place to get the VM, Ubuntu 16.04, and just download it from there.
Hey, Professor Calix, I think Josh is waiting for you to let him in.
Is he? Okay, yes. I'm sorry. Let me see. Yeah, there's a couple of people actually.
Emilio had to restart his router.
Yeah, I've had horror stories with Zoom, so I don't know. You're actually the first class I've had today where it's gone smoothly so far. All right, so anyway, so hopefully I've added everyone now. Anyway, so as I was saying, you can get the VM from the website, the Seed Labs website. Later in the semester for your project, you will need another VM, and for that one, I just recommend that you get the latest, either 16.04 or 18. Just get the latest VM, and that will be for the term project, because you're going to be doing some configuration, and for that one, it's probably more recommended that you start with a more baseline version of Ubuntu versus the Seed Labs VM, which has a lot of configurations, as you know. All right, so before we get to the syllabus, I like to go over the course website. So as you know, I provided this link. I like to have a separate way of providing the information in a different way. Okay, so some of it is repetitive, but as you know, here is the description of the course. This is software assurance. All right, so as you can see, software, right? So the focus of this class will be coding, all right? But in particular, you're very advanced in coding at this point. And so really what we're looking at is not learning new things about coding, but instead learning about how can we write secure code. So I just admitted someone else. Okay, so that's the goal of this class, right? Okay, someone else came in. All right. Okay, so the focus of the class is software assurance, and as I was saying, the goal is to write code that is to assure the code. And that means two things. We want to write code that has quality and code that has security. So software assurance is about these two ideas. It's not just that the code needs to be secure, against hackers and things, but it's also that the code needs to be high quality. All right, so quality code. All right, and that when I say quality code, I just mean that, maybe whenever you create let's say a website, right, maybe nobody can hack it, but if somebody clicks on something and it's a broken link, that's still not meeting the requirement of assurance because quality is not there. And so that's really what the course is about. A lot of the topics that we will cover are related to security, however, and so it's important that you're aware of that. So basically, let's go over the description. So this course covers defensive programming techniques, things like bounds analysis, which is basically checking, that we don't have things like off by one errors. It focuses on error handling. As I said, the example I gave of the website. So if there's a broken link, how do you handle that error? Testing techniques, so we will talk about that. There's something called white box testing, black box testing, so we'll cover those procedures, and you might even do a little bit of that in your term project. It's very straightforward, but it's just how do you devise a testing plan so that you can check the assurance of your website. Detailed code auditing, which is really about reading code. That's something that, in this class, most of the time, I give you the code already. So you're not going to be writing the code from scratch, but you will have to read a lot of code. Okay, so that's important. Software specification in a trusted environment, right? So software specification just means, okay, the associated documents that define a piece of code. Okay. So this will have a lot of labs. This class has definitely, one lab a week or a lab every 2 weeks. It varies. So the topics include, and these are not all the topics, but some of the main topics are buffer overflows, web same origin policy, XSS, which is cross-site scripting, web-based worms, e-commerce security, and more. Okay, so as you can see, there's going to be several programming languages that are involved in this class. We're going to mainly focus on C and C++ for the first 5 weeks, 5 to 6 weeks. We're going to look at software assurance in the C++ domain. And that's important because that's the area where you have, a lot of, whenever they say patch your software, or, this Windows issued a new patch, or Linux or Mac, it just means, the code that's written at a very low level. It's C++. And so we're going to explore how that works. What are the software issues that might create vulnerabilities, right? So someone else just came in. So I think everyone is in now, hopefully. All right, so as I was saying, so the first 4 or 5 weeks will be about C++ type of security. Very interesting topics, buffer overflows, and a few other things. I usually like to have a practical exam at the end of that stretch. So we're going to do 4 to 5 weeks of that, and then you get one practical exam, which will be an in-class, hour and a half, that you have to solve a problem. So it should be pretty fun. Or stressful, depending on how you see a challenge. Okay, so then after that, as you can see, the other topics have a tendency to talk about web things. So the other area that we're going to cover is web security, internet, website security. So that involves the classic examples of SQL injections, JavaScript injections, and so on. Okay, and so we will explore all of those as well. As you know, JavaScript is a very powerful programming language for browsers. SQL is for databases, but they can also be vulnerable. And so the common theme there, we start with same origin policy, and that is basically how browsers should be structured to have security. And then from there, what are some of the things that could be vulnerabilities in your websites? All right, and so, you guys are IT students, so it makes sense that the C++ or the IT, the web development software domains are covered in this class. You can see one of the last one says e-commerce security. And so basically the project this semester is that you will take an e-commerce website and secure it. This e-commerce security project is fairly complex and quite extensive. So usually I recommend that students taking ITS 450 should have taken ITS 362 before. 362 is the PHP, jQuery, JavaScript, MySQL class, where you should have learned how to build a database-driven, dynamic web application from scratch, right? Using those languages. 450 uses the same exact technologies, except that I give you the code. And if you think about it, in 362, you also learn how to program in MVC, model view control, in that approach. And the code that I'm going to give you for that e-commerce is also written in MVC. So that's why it's important. You know, you'll be doing a lot of code auditing because the code that I'm giving you is broken in certain areas, or it's insecure in certain areas. And so you have to basically fix it. That's really, so the idea with the term project, it's something like this. A company had a great developer who was building an e-commerce site, but the developer left before he or she finished the e-commerce site. And so now they've hired you and you have to complete the task. And a lot of the security was not there, or maybe it was there, but you just have to make sure. And so that's really the project. So the project, you don't build the e-commerce from scratch, but because you've already taken 362 and understand all of that, you should be able to finalize the project, all right, and secure it. Remember, and really provide software assurance in both quality and security. So that means, you know, everything should work and so on. So it should be a pretty fun term project. It will be worth 30% of your grade. So definitely, you know, because the grade needs to reflect the amount of time that you will spend on it. A lot of the web security topics will apply to that term project. So a lot of the things that you'll be doing for the labs are then things that you can also explore in the e-commerce project. The CC++ buffer overflows doesn't really apply to the project that much, but it's just, you know, we have to cover it because this class is not a web security class. This is a software assurance class. So we cover a couple of the more important, you know, programming languages and explore this idea of software assurance. You can obviously, once you understand what software assurance entails, you can easily just apply it to any other programming language. For those of you that like Java, there is a Java course. I think it's called Java Software Assurance, I believe. And that's usually off in our program here. So I think it's a 400 level class. And you can ask either Professor Michael too, and when he's offering it, and you can also take that as well. That one, the focus is on Java. Okay. Are there any questions so far? Okay, no questions. Let's continue then. So the class is going to take place Tuesdays and Thursdays, 6 to 8 p.m. Okay. Okay, let's see. I have a question in the chat.
Jesus Christ.
Oh, there, sir.
Did someone had a question?
Dude, I screwed up my class.
Are there any questions, guys?
Not for me.
Okay.
Not right now.
Okay, all right.
Nope.
Somebody wrote something. Okay. Okay, all right, so I thought somebody had written something. Anyway, so we're gonna meet Tuesdays and Thursdays, 6 to 8. Here's the information on the book. This is actually one of the classes that ties in most to the book. All right, so I think a lot of you already have the book, Computer and Internet Security, A Hands-On Approach by Winland Du. And we are really, pretty much every lab ties to a chapter in this book. So definitely, if this is one class where you should have this book, okay? It'll help you a lot. You know, obviously, as always, I will explain everything and I will provide examples of everything. But if you want to do some reading beforehand, you can go ahead and purchase the textbook, and it should really help you with this lab. some of it, this lab is, I wouldn't describe this lab as an easy, or this class as an easy class. There's quite a bit of things. There's a lot of topics. Actually, I think it would be surprising to some of you, right? Whenever you think of software assurance, you might think of just one thing. But it turns out that this topic, software assurance, is actually there's a lot of examples, at least, of software, of software vulnerabilities, etc. And so we will explore them through the lab. So if you don't know me, I'm Professor Calix. Okay, my email is there. Emailing me is really the best way to get in contact with me. I usually check every day, so I should be able to reply as soon as possible. Videos. Okay, so as I said before, you should attend class, via this synchronous online approach. However, I am recording every video. So believe it or not, after the class, I have to spend a couple of hours, going over the videos, loading them and everything. But I'm doing that. So after this session, for instance, I'll save the video and load it. I'm putting everything on YouTube. I find that that's, it's just simplest, more reliable place to put them. And then I will provide a link to the videos, which, as I did last semester, I tie them to the calendar. So I've already put together the calendar for the fall 2020. It's got all the holidays. And then today is, of course, the 25th. So later tonight, when the video is recorded, I will post the link there, and you can take a look at it again for any instructions, etc. So I'll do that for every session, and so on. So they're all in a YouTube channel. So I've also provided the channel in case you somehow find that easier. All right, so the lab. So what are these? This is a list of all the labs, or a lot of the labs that we're going to do. So this week, we will start with something called the SetUID lab. So I'm pretty sure you guys have taken 372 already, and you might remember that in 372, I first introduced the concept of SetUID. Okay. So I will explain this in a little bit more detail, either on Thursday or next Tuesday. I will start, I use the whiteboard a lot, and I will use it again, start writing a few descriptions of SetUID. So the first lab will focus almost entirely on just this, a vulnerability of SetUID. So I described SetUID in 372, and that's really the topic for this week. So we will, later on today, probably I'll come back to SetUID and we'll start talking about it. But other labs include one called Format String. Then we have two buffer overflow vulnerability labs. One is just the main lab, and the second one is going to be the practical exam. So remember, so around week 4 or 5, we will have a practical exam that will probably involve mainly buffer overflow vulnerability. So it'll be an in-class, hour and 30 minutes, sort of like a quiz practical exam, where you have to, you basically have to get a shell, get a terminal by exploiting a buffer overflow vulnerability. After that, after buffer overflows, we're going to switch gears to web security, basically. And when we do that, we start looking at, SQL injections, cross-site scripting, something called cross-site request forgery, and web same origin policy. So those labs, some of them are much longer, and some of them, I think the WebSop is pretty short. WebSop is actually just a review of like JavaScript as well. So because, JavaScript, obviously, as you might imagine, it being a programming language on your client-side browser might, be something that you have to provide assurance for. All right, then we will explore a few other topics like integer security, white box and black box testing. And then we will conclude with a few special topics if there's anything of of interest that, you know, currently we should take a look at. But mainly these are the main ideas. And then finally, of course, there will be our term project, which I will talk a lot about later on. But it's a very, very complete e-commerce site. It's not an e-commerce site that uses like PayPal. Instead, it's the kind of website where you have to have a credit card clearinghouse. So the idea is you're building an e-commerce site where people actually enter their credit card information. And so obviously that implies quite a bit, including encryption. And so we will spend some time talking about that. But it's a really great project because it brings together some of the concepts from 350. It brings together a lot of the web security concepts from this class, and it's really an interesting thing. All right, so I talked about the VM. So, you know, there's the link again to download it. And then as you can see here, this is the fall 2020 calendar. Currently, you know, I'm updating it every week as we get through the materials, and I'm adding all the relevant links, the videos that I've recorded. Holidays of note, October 13th is fall break. November 26th is Thanksgiving. And then finals week will be the week of December 14th through the 18th. Project presentations will be December 8th and December 10th. Okay, so just be aware of those important dates. Exams will be, as I said, on week 6, week 12, and the week of finals. All right, so now that we've covered the website, we can go ahead and switch back to the syllabus. So let's go ahead and open the syllabus here. So let's get to the syllabus. All right, can you see the syllabus now?
Yes, we can see it.
Yeah.
I see it in all its magnificent glory.
All right, so this is our course syllabus. Of course, we want to go through this. You know, so ITS 450, software assurance. Now, actually, there's only one required book in this class, but there is one book that I do recommend that you get. Okay, and you can see it here. I've listed the books. So the required book, I would say, is Computer and Internet Security, A Hands-On Approach by Weng Liang Du. As I've said, it's an excellent book for 450. Get it. Another book that might be very useful and might make your life easier for the term project is this book, Effortless E-Commerce with PHP and MySQL by Larry Ullman. Just get the latest edition of it, whatever it is. I highly recommend this book. Okay, as you can see, it's e-commerce now with PHP and MySQL, and it really, the focus is on software assurance and developing the site. So what I do usually is I provide the code for this. So I will be posting the code on Brightspace at some point, and then you will have to download that code and load it on your VM that you're going to build from scratch. And you're going to have to do a lot of work this semester to get that e-commerce site to be fully functional and to meet the conditions of software assurance for both quality and security. So as you can see, that's quite a bit of work. Okay, you will need to be a system administrator in that virtual machine so that you can control the application, so you can control the database and so on. Okay, so I do recommend that you get this other book as well. I don't think it's very expensive, and actually start reading it. If you've taken 362 already, then you know everything will be very, very familiar. If there's anyone that hasn't taken 362, then I now even more strongly recommend that you get this book. So this book will get you up to speed on the project. Okay, so that's just a recommendation. All right, so here's a list of the topics, the core learning outcomes and learning objectives. So you can take a read through it, but I've already pretty much said a lot of this. Okay. All right, the grading criteria. I know you're usually concerned with the grading criteria. So we will have 3 exams, exam 1, exam 2, and exam 3. They will be on week 6, week 12, and the week of finals. That's 30% of your grade. 10% of your grade is going to be quizzes, you know, like the kind of quiz that I mentioned before that we might have where we do a practical exam on buffer overflows. Okay. Also, you know, just attendance, you know, professionalism in the classroom and teamwork. This is, you know, because we have such a big and stressful project this semester, it's 30% of your grade, you might have a little bit of conflict there. So make sure you're doing your part, okay, in the project. The other thing, so that's going to be just 10% of your grade. Then we have the labs and homework. As you can see, that's going to be 30% of your grade. And then finally, the term project is 30% of your grade. So it's weighted heavily. The project has a heavy weight this semester, okay? All right, then please read through all the policies. You guys have taken courses with me. You know the basic things are submit your homework on time. You have to submit your homework assignments through Brightspace, right? I don't accept late homework, so those are the main things. Okay. And then that pretty much wraps up. Remember, you submit reports, so that's not going to change, with evidence that you completed your tasks. For emergency, you know, there's this. Also for during this pandemic, mental health issues, you can always contact the office for that here at the university. All right, so finally in the syllabus we have, you know, I have a list of topics. Again, this week we will start with the set UID lab. Then we have format string. Today I like to motivate the class a little bit, so I will spend some time just on review. I'll give you a few slides that you can read it by yourself, reviewing the terminology of security, and then after that, I kind of have some fun examples of things that have gone wrong with software, right? Because that could never happen. All right, so we'll look at that a little bit. Some of the cases kind of illustrate, you know, why this is important. Then, as I said, buffer overflows is one of the big topics in those first 4 weeks. You can see there that falls under the description of something called code injections. Okay. Then after that, we're going to start with web security and look at those topics of cross-site scripting, of JavaScript security and SQL security. And then at the end, we might have some special topics. And of course, I'll give you a little bit of time to work on your term project. Because the project is such a big thing, I usually like to start the project early on. So as soon as we are done with this section on C and C++, we will basically, and I start discussing the web security topics, I will also just introduce the project, okay? So that you guys can get started with it. All right, and that concludes my description of the syllabus. Are there any questions on the syllabus?
Nope.
No questions. All right. So now that we're done with the syllabus, let's stop sharing here. Let's go to, let me open.
Dice Junior que ya hizo me la pone.
Let me open the slides, and we're going to get started with the slides. And then after that, I will talk a little bit about the lab. Remember, we're going to start the lab on Thursday. So I recommend that you get the VM running, your seed VM. Most of you are familiar with it already. And so it should be pretty easy. You just need one, you really just need one version, instance of the VM. Make sure you have VM and everything. All right. So hopefully, can you see the slides?
No.
No. Okay. Share it. Okay, so now you should be seeing the slides. I'm sharing them with you.
We can see them.
Yeah, okay, great. All right, so let's get started then. So as I said, this is basically for you to read through. There's some of it is just like a review, and then other things are basically just motivation. What has happened, kind of some scenarios of what has happened, what has gone wrong that has cost money because of errors in software development. All right, so let's get started. All right, so as you can see, this area, or this the first few weeks of software assurance will be focused on C and C++. So the great languages of C, C++ that are very much relevant today, right? They're still like essential. They're the most, I would say probably the most important language available today for a lot of applications. Okay. So, okay, maybe I'm gonna mute. All right, let me mute some of you. Okay, so I muted some of you. If you have any questions for whatever reason, just raise your hand, or just send me a message so I can unmute you. But for now, I'm muting you, just so it's easier. Okay. All right. So so secure coding with C and C++. That's where we're going to get started. We're going to talk about what are the threats. So we really have to understand, right? So first of all, why do we use C and C++? Who can tell me why do you program sometimes in C and C++?
It's faster.
It's faster, exactly. Very good answer. Why is it faster?
It's because how it compiles your code, the way it compiles your code.
It compiles it. Another way of answering that is saying that it's because you write code that has fewer abstractions. That is to say, it's code that is closer to the hardware. Does that make sense?
Right. Yeah.
So, right. So whenever you're, it's not like Python. So first of all, I'm sure most of you know, Python is really just an interface to C and C++. So people love Python because it's a simplification of the language, but with the efficiency of C, C++, because whenever you use a Python library, the binaries that are running in the background for that library are actually C and C++ libraries. So it's still going to run at the speed of, or not exactly the exact speed of C, but it's pretty close for some aspects of it. However, you do have the whole overhead of Python, right? Of the interpreting of the language and so on. And so that's, that's a good example of why C and C++ is different, let's say, to a higher level language like Python, is that Python has more abstraction at the top because it makes the language more readable, simpler, better, easier to understand, right? And so whereas C, you guys have taken C and C++ in your courses, and you know that C is a slightly harder language to learn, has more complex syntax. So for instance, I ask you this question: how many data types do you have to define in Python? Whenever you write a Python program and you have to use variables, how many data types are you required to define before you can use it?
It's 6, isn't there?
There might be 6 classifications, but whenever you create a Python variable, first of all, do you declare a data type for it?
No.
No, right? Exactly. Very good. So you don't, because there's a little bit of more abstraction. There's code basically at that level that handles data types for you. You see that? So it makes sure that you have a little bit more control, or rather, I should say, you have less control, but it's easier. C, on the other hand, is the total opposite. Whenever you're writing a program in C and C++, and you have to declare a variable, how many data types do you have available for you? Just roughly. You don't have to tell me the exact number, but just roughly. So it turns out that just for integer, you might have more than 6. And then for float, you might have more than 6. You see that? So you have a lot more data types, because when you're writing in C and C++, you're basically, you have more control over what you're doing. Imagine, for instance, that you're building an Internet of Things device, and that device has limited memory, limited hard disk space, and so on. So you really want to have good control of the space that you are allocating for every task. Do you see that, guys? See that idea? That you have more control over, the size of the variables. And so sometimes it turns out that you want to maybe not waste memory, because you cannot afford to waste memory. So you don't need to have a 16-bit variable. You just need to have an 8-bit variable. And so you define variables that take up less space and just provide more efficiency for your code development. Is that clear? So this is a fundamental concept, because by having all this control over what you can do and allocating memory, and by having all this flexibility, you also have more room for error. You have a lot more room for error, basically. Okay? And so, a lot of the issues with secure coding simply have to do with, 2 things: either lack of knowledge of the programming language or the vulnerability, or possibly an oversight that you knew about it, but you kind of just, missed it, right? But they're basically human errors that you implement in there, okay? And so, that's why today I'm going to kind of motivate some examples, right? Because that will illustrate what can happen. So hopefully we've established at this point something very important though. Languages like Java and Python are less prone to error or vulnerabilities, security vulnerabilities, because they have more abstraction. They're more higher level languages, as they're called. They have less flexibility, and they're not as close to the hardware as C and C++. On the other end of that spectrum, C and C++ provide a lot more flexibility, a lot more power. They're faster because there's a lot less overhead. They're compiled languages, etc. But at the same time, there's more room for error. There's more room for somebody because you're literally, the program now is literally, you're creating something that is pointing. You know, you have, I'm sure when you took your C and C++ courses, you discussed pointers, things like that. And now you're creating programs that basically say, you know what, I'm going to execute this instruction and the next instruction is located in this place in memory. And the mechanism in C is literally just a point to memory. So what if a hacker or a bad guy, bad person decides, you know what, I'm going to find a way to change that pointer. And so that pointer now will not point to the data, but will actually point to another location in memory. And then at that point, you've corrupted the program. You've changed the flow of how the instruction should be given. Okay, so that's what I want you to understand is that in a language like C and C++, you're really creating, when you create variables and things like that, you're creating really pointers to memory, addresses to memory. And those addresses are stored in yet other places in memory. And so now, through the inputs of the program, because those inputs are actually writing values into the variables, which are in memory, you can see how somebody can try to think about how to exploit that whole mechanism to make those pointers jump from one place in memory to another, from a place in memory that should have data to a place in memory that has instructions and vice versa. And so that's going to be the little game that we're going to play in the next 3-4 weeks related to software assurance at a very low level, hardware level kind of programming with C and C++. And so this week we will start with the easiest. We will start with the easiest introduction to that, which is the set UID lab. It should be a pretty straightforward lab just to kind of get us thinking about that. Then we're going to do the format string lab, which allows us to play with memory a little bit more. But really, all that those two labs do besides showing the vulnerability is that they are getting us ready for the buffer overflow lab. Where the buffer overflow lab, we have a lot of elements that come together to achieve an objective. Okay? Is that clear, guys? This explanation?
Yes.
Okay, all right, great. So are there any questions about it? Okay.
Nope.
No questions, Izzy. Great. All right. We'll come back to it certainly. I mean, what I just described is a condensed, description of what we're doing for 4 weeks. So we're kind of just going to look at all the details of it, and that's it. So anyway, so here are some examples historically over the years of what has happened that has caused disruptions. So we know there's internet worms. We will actually implement a web-based worm at some point later in the semester. It's going to be JavaScript. But as you know, these are just some examples of software that causes problems. Okay, so worms. And then historically, we have these that you can look at. Additionally, there's just some terminology, what is risk and everything, so you can take a look at that. What is a threat? So this is just a review of terms. I'll leave it to you to read. I really just want to get, you know what hackers are and things like that. So definitely read through this. Security concepts, again, I always kind of like to start from the beginning. So here are all the definitions. Keep in mind that we're talking about computer security, but from the point of view of the software, right? So we have to talk then about the programmer. Okay. And I've said already that the programmer is really the reason why there's errors in the code. So usually programs would have no errors if the programmer did everything perfectly. But because programmers are humans and humans make mistakes, then what happens is that the mistakes get added into the software, and then you have applications that, you know, make mistakes. Okay, so additional terminology, you can go through that. These are all things you're familiar with. Relationship between concepts. Security policy, you know what that is, so you can take a look at that. Software defects and flaws, as I said, that's just you know, something that could result as a human error, basically what I just previously said. That can lead to vulnerabilities. However, I stress that this class, a programmer error won't always result in a security problem, but it can result in a quality problem. And so we have both of those elements in software assurance. Exploits. So what's an exploit? Who can tell me what's an exploit? Anyone? What's an exploit? Well, it's written right there, right? So an exploit is a piece of software or technique that takes advantage of a security vulnerability to violate an explicit or implicit security policy, right? So it's something that, you know, so if you remember, for instance, how many of you remember Metasploit in 250? Who remembers that? Are you guys still there? Did you fall asleep? All right, so
We're here.
yeah. So if you remember, when you took 250, you probably did Metasploit, or you used Kali Linux to do a lot of attacks, basically on machines. So what you were doing there is that you were running exploits, right? You were running basically, I think with Metasploit, it's like Ruby code. So what do you think? Let's see. What do you think that code was doing? Usually, you started with a computer like Kali Linux, and you targeted another computer, and then you pressed the button, and what did you usually get if you were successful? How did you know that you were successful in your exploit? Anyone? All right, I'm going to call on you.
Wouldn't we know we were successful in our exploit if the exploit was, we tested the exploit and it worked?
And what did you usually want to get with an exploit? What was
admin access, for example?
admin access, right? Exactly. So that meant basically getting what? A terminal, a shell, right? You remember
Depending
that?
on what you're going for, yes.
Yeah, usually, yeah, that's like the classic example. Exactly. Good. Thank you. So the reason why I bring up Metasploit is that back then you were just using a tool to try to achieve. So back then you were using Metasploit, targeting a computer, something like Windows, and you were trying to send some packets. And then when you sent those packets, you would know that you were successful because you got a terminal. And so what the first 4 weeks of this class are basically about that same idea, except that the focus now is not so much on using Metasploit and, you know, all right, let's try this exploit or that exploit, but instead we just want to understand the underlying reason why you were successful, okay? And usually that results in programs that were written maybe in C, C++, and they had a vulnerability, right? A vulnerability in the software. And so basically what would happen with those programs, they're usually daemons that are listening on a specific port for inputs. And so what happens is you send, as you send the communication, you send data, you send what is an explicitly crafted code injection, okay? So you're, where it's expecting an input like your name and password or some value, you know, you can actually inject characters in a specific way you know, a code injection, and you're going to exploit a vulnerability in the way that maybe the variables were allocated, like the memory was allocated. So you're going to exploit that to overwrite space or information in memory. And by overwriting that with the information that you want to inject, you can actually then achieve things like injecting the code for a shell and triggering that code so that you can actually get access to the machine. Does that idea make sense, guys? So that's what we're doing in the next 4 weeks. So as I said, as contrast, in 250, you were just learning, okay, I have this machine, so I'm going to use this exploit, see if I can get a terminal. Now we're going to explore in more depth in this class how that whole mechanism works. Okay, and so we will spend a little bit of time just on that, you know, on describing. We're going to talk about memory, the stack in memory, which is a place in memory that's for functions. And then we're going to think about how information is organized in the stack. And then we're going to need to learn, you know, what is the size of each allocation there? And then how is information placed in that stack when you're calling it from a function? Where do we put the variables? Where do we put the return pointer? Where do we put this and that? And by knowing that whole structure, then you're going to start thinking about how to inject code to overwrite spaces in memory and then do several steps so that you can eventually end up with a shell. Okay, so hopefully that makes sense. That is that what I just described is basically the whole mechanism that we're going to look at. So that one idea that I just described is what we'll be doing for a few weeks. And you'll be doing several labs about it, you know, getting the terminal in several ways and so on. All right. If you have any questions, please stop me at any time, you know, just ask anything. Okay. So one thing that I mentioned, one word that is important is inputs, right? I said that you send an input to the system. So, and the system has a vulnerability that if you craft your injection in the correct way, you'll be able to exploit that vulnerability. But for you to be successful, first of all, there has to be an input. So you have to send some data into the system. So what are some controls that you could think of to prevent somebody from creating a code injection, injecting it into the program, and, you know, obtaining a shell? What would you say? What are some controls that you can have in place?
Validating?
Say that again, sorry?
Validating, like if it's to be a digit or just like any kind of character instead of like if it's a digit instead of like a letter or something like that.
Perfect. Exactly. That's it. I always tell students that basically this whole class, every problem, every vulnerability that we're going to explore, the solution comes down to input validation. If you do, you know, remove the bugs in your code and then you just have proper input validation, you can stop all attacks, or you know, almost all attacks. And exactly, good answer. So input validation is ultimately the thing that you need to prevent issues with software. Okay, so thank you. All right, so let's continue with some of the description. All right, so let me. All right, here we go. Okay, so just this goes into a little bit more detail about exploits. You can read through that. Mitigations, we've talked about it already. We talked about C. I already kind of went over this. This explanation is very popular programming language, and I explained. Basically, what is the problem with C? We talked about this. So C does not protect programmers. And basically, Problems arise from an imprecise understanding of the semantics of logical abstractions and how they translate into machine level instructions. So although we're not going to look at assembler or machine code, here, for us to get a proper understanding of buffer overflows, some of those concepts become relevant. Okay, so we're going to we're going to start looking at how code, as you know, code is compiled, right? So you go from the human readable code in C, C++, and then you compile that into machine code. And there's several levels in between, like hexadecimal code, etc. And so we will see that as well, those elements of how, because for instance, when we inject code, right, we can't inject code as we see it in the C, C++ editor. That code is not compiled, so inside in memory would not be able to interpret that code. So it makes sense that the code that we inject in memory has to be the code, or how the code would look after it's been compiled. And so we're going to have to just get some intuition of how that works. If we have some C code, what is the equivalent of that in compiled code? And so we'll look at some programs that help us to do that. So some of the labs also address that as well. Okay. So we talked about, what is the problem with C? So I already mentioned this, programmer errors, failing to prevent writing beyond the boundaries of an array. And that's really the key thing, because a lot of C is pointers. It's basically this idea that you point to the start of the data in memory, and then you just tell it what the size will be. But sometimes a program will, you can grab a pointer and just start reading, right? And it never stops. And so that's really one of the problems of this, is that if we're not checking the limits of an array, we're just going to continue reading in memory for a very long time. Okay? And so that's really important. We also have errors related to integer overflows or truncations, which that can happen when, in particular, that can happen when you assign data types that are not big enough. Okay, so we know, for instance, that, how many numbers can we represent with 8 bits? How many numbers? Who can tell me that? How many numbers can we represent with 8 bits or 1 byte?
Is it 2?
Not 2, not with a bit. With 8 bits. 8 bits.
256.
1 byte.
You have 8 bits, right? 8 bits, which is 1 byte. How many numbers can you represent with that?
256.
256, right?
Oh, I get it.
Right. But if we want something bigger, let's say we might need, a larger variable, right? So that's going to be maybe 2 bytes, which would be 16 bits. So that's definitely going to give us what? What's the number for that? It's like 65,000 or something, right? So now what would happen if you build a program in C where the numbers are going to range from 0 to 50,000, but the variable that you choose is only 1 byte in size? What do you think will happen? So obviously, if we can only represent from 0 to 256, we have a problem there, right? Because 50,000 is not going to fit in that variable. And so what might happen is that we end up with what is called a truncation. The number just gets, we get unexpected behavior, basically. And so that's another type of problem that can happen, and that's just the programmer didn't think, right? That you just used this variable, but you didn't quite think of the limits, or you never expected that a value would become that large, and that can happen. What's the classic example of that idea? Can anyone tell me? What's the classic example of that? Of creating variables that you never expected that we're going to need to store larger values than the values you initially used or thought about. What's the classic example? Do you guys remember something called Y2K? Probably didn't live through it, but do you remember what Y2K is? Nobody?
Yeah, I was around for it.
Yeah, so Y2K is, so what was Y2K? Who can tell me? What was Y2K?
Wasn't it that nobody thought that computers would be able to like comprehend any time past like the end of the world or end of 1999?
That's right. That's right. So when they created, when they first created computers in the 90s, the programmers, pretty much everyone, you know, they wanted to be efficient in their memory allocations. That was the first thing. That was the, you know, they didn't want to waste memory. And so they only said, well, you know, we're going to build a two-digit variable, right? So, you know, so your 1999 was going to be 99. And 1902 is 02. But what happens when you get to 2002? Is that 02 2002 or 1990 or 1902? Do you see that? Do you see the problem? And that was Y2K, and that actually happened, right? Everybody thought all the computers in the world were going to crash, but they fixed the problem, and it came down simply to the fact that when they programmed systems, they were trying to be careful with their memory allocation, and therefore they just didn't give it enough memory or enough size. And so that cost a lot of money to fix, right? That cost a lot, and people spent a lot of money on programmers just to, you know, people were saying like, oh, we need to update our systems for Y2K and so on. Anyway, so that's a classic example of that. And so as you can see, you know, all I'm doing today and the rest of the class is really just kind of motivating what we're talking about here. You know, that is really little errors that you make in software, maybe in the design. You know, that Y2K was just a lack of imagination issue, right? People thought, maybe they thought that, you know, every system was going to be reinvented by 2000. And they never realized that maybe sometimes you build a program and it's going to be there for a long time. Okay. There's still, I can't remember what it is, but there's still some systems running on Fortran or something. I want to say it has to do with the Treasury. But I can't remember what it is, but it's amazing that the systems that they're using are very old, and they're still running on very legacy software. So it's still around. By no means should you ever think that C++ is a legacy. C++ is very important, as important or more important today than before. So, but certainly there's a, you know, these are the issues that you can encounter because of all its power, as we've been discussing. Okay, and so on, right? So we've talked about this, you know, what is the problem with C? So I think that kind of motivates the idea there with C. So it's the short-term solutions, you know, educating developers on how to program securely. So that's why you have this class. Because at least after you've taken this class, which covers both C and web security, you will now, whenever you build a program or an application, you will, you know, we'll spend a whole semester on this. So you will always think, oh, by the way, I have to check inputs. That's important. And there's certain things that you'll have to consider. And if you're writing C code, you have to be especially careful. Okay, and so that's, you know, important. Sometimes you do get a lot of help, like with compilers. As you will see, the compilers that we're using actually in the lab, sometimes we'll have to disable certain security features just so that we can exploit a buffer, right? And so you will see that the compilers actually now have, there's mechanisms in them that are there to try to prevent these vulnerabilities, or at least not, maybe not prevent them, but at least reduce the chances or the likelihood that they will happen. Okay? All right. All right, as I said, I don't want you to, this slide, I don't want you to think that C++ is a legacy, but there is still a lot of code that was written a long time ago, maybe like when under the same principles of Y2K. Back then the parameters were good, but maybe today the numbers have gotten larger, and so that can result in unexpected behavior. Other languages, I already talked about Python. Other people love Java. I like C and C++ a little bit more than Java, but Java is supposed to be more secure, but it's sometimes not a viable option for certain things. Okay, but Java, the reason that Java might be more secure is that it has a little bit more overhead to protect the programmer. Okay, and that's basically the idea. It's got more functions, more subroutines to ensure that the code that you're writing is secure. Okay. All right, I've talked about levels of abstraction already. So I talked about C and C++. I talked about that. Basically, understanding, looking at a lot, this is basically saying looking at a lot of examples is a good way of better understanding software assurance. Okay. All right, so then we're going to talk about debugging. As you know, whenever you're writing code, a lot of it is just debugging, making sure there are no errors. So that's equivalent to testing the code, right? So you're, as a programmer, and that's usually what's called white box testing, which basically means that you're just writing the code, running it, making sure everything runs smoothly. But you always have bugs. That's very difficult to remove completely. So we develop programs that contain defects. Question is how many? It's hard to predict the future. However, it is likely that the software we all write, including you, will develop in the future, will have errors. Okay, so that's like, this is just like a reality that you have to accept. That no matter how hard you try, there could be errors in your logic. Maybe your syntax is perfect, but your logic might be flawed. Maybe it's just that it was a lack of imagination. You never thought, you're like, I never thought that there could be a pandemic, or something like that. And it just changes everything. Okay. All right. The sources of the problem for your code. We've talked a lot about how the programmer makes the errors ultimately, but sometimes it's poor design. So maybe there's a misunderstanding in what you were trying to develop, or when you designed it, there's a fundamental design flaw in the software. So there's basically a process. You go from an original idea to kind of hashing out the program, creating the diagrams of the code, the whole documentation of it, then going through the process of developing the code, implementing it, and then you shouldn't forget that the code should be tested thoroughly before you have users use it. As you know, in the real world, it doesn't work that way. Companies are constantly developing their software solutions and updating later. I mean, Windows is famous for that. They're literally updating all the time. And, even nowadays, like applications, like I said to you guys this morning, Zoom updated something in my software that broke so many things. Okay. And then, of course, not testing the code properly, that can be a problem. And also, in the future, the code needs to adapt, right? So you always have to improve it. All right, are there any questions so far with anything that I've said? Questions, comments? No questions or comments? Wrote something in the chat. Nope. Okay, so let's continue. Let me just for a sec, now that everyone is here, I think I have to take the roll. I'm going to take a picture of everyone. Make sure you put your full name on these so I can always identify you. All right, great. All right, so let's keep going as we motivate this, this topic. All right, so now, so now in the next set of slides, as you can see here, we're just going to look at several simple examples of what has gone wrong in code. You know, what are some possibilities? So as you can see, whenever, and a lot of this is pseudocode, by the way, or specific languages. But you can see here, for instance, you know, syntax errors can result in problems. So Project Mercury, you know, which is related to space flight, right? That, you know, they had an error in the code, and you know, the systems were not generating the appropriate data, and it could be something as simple as just a syntax error, which, you know, might be, instead of being a range, it might think it's just a specific single value. Okay, in this case, because if you look at this problem, here you're indicating do this 10 times in a range. Here you're saying 1.1, that's just a number, and if the program automatically uses typecasting or truncation, it might truncate this value to just 1. So it'll interpret it correctly as a 1. And so that, you know, that's an example of an error. In aviation, in flight simulators in particular, right? You know, I believe this example had to do with the fact that coordinates are negative, apparently, south of the equator. They never thought of that, and so the simulator didn't work correctly. This one we talked about, year ambiguities, right? In Y2K, when somebody reached 2001, the system would think they are 1, which basically means that is important because in terms of auto insurance, I think the insurance rate for an older person versus a baby that is 1 would be different. And so the system might interpret that incorrectly. All right, and so you can see these are simple errors that we've all made programming, but that have strong implications sometimes in the system, especially because the system doesn't use that, but eventually it gets to it. There's a classic example of one of these rovers that they sent to Mars. And I believe this happened a decade ago or so. And this rover had a microphone. So when it was going to land on Mars, and then the microphone was going to be able to record the audio on Mars, but then the system crashed, or the rover crashed. Anyone know what the cost of the crash was? I can tell you it was a software error, but anyone here familiar with that story? Anyone know what happened? It's funny. It's almost like tragic. What such a small mistake. So apparently the rover has these sensors, right? So as it was trying to land or navigate or something, it needs to read the sensors and then make calculations to adjust its, thrusters and everything. Well, what happened was that the software was written by two teams, two separate teams, by the way. One team, let's say in America, one team in the United Kingdom. And as it turns out, the system of measurements that is used in the United States, it's not the metric system, right? So it's based on like inches and feet, whereas in Europe they were using the metric system. And so what happened was one module was written in one set of measurements, the other one was in the other, and when the two communicated, they just provided obviously very wrong information. And so that resulted in that crash. So you can look this up. That cost, I'm sure, millions of dollars in the cost of losing that equipment. And it was a simple error. Now keep in mind, that error it's basically just it's not a bad implementation error. I'm sure they were probably great C coders. It was just a design error. It happened somewhere early in the stage of development. So it was a design error, and it was a reliability error. So it had nothing to do with security. It had to do with quality, that they did not check that. All right, and so that's it. So whenever I discuss this class, software assurance, as I said, that's what we're talking about. It's simple things, simple things. A programmer writing some code in a specific language, and that specific language has, because of various things, errors that result in unexpected behavior. Maybe if they had run simulations of the code of the actual orbit or landing, they would have been able to catch that error in the software. So maybe they should have had a little bit more testing of the software in action to prevent those errors. So testing is really important in these situations. And so that's the idea. So I'm not going to go through all the examples here in the slides. I'm going to let you guys kind of just take a look at them. But as you can see, sometimes errors in machines can really cause harm to people if you're not careful. Okay, so historically, these have been some of the most important ones. I like to mention this one about the Bank of New York because it's important. It's something as trivial as the Bank of New York had a 32 billion overdraft as the result of a 16-bit integer countant that went unchecked. Eventually, they were able to fix the bug, right? So you might imagine that they went into the code and fixed the issue of the 16-bit integer counter, but the money was moved somehow. And so they didn't have, for a while, this large amount of money. And so that means that cost them, basically, it was a cost that they had to absorb in terms of fees. And here you can see it. The bug cost Bank of New York $5 million in interest payments just because of a simple software error. So, that can happen, right? You write some code and eventually it has some unexpected behavior that can have some serious implications. That's why, so now that we've talked about this, you know that airplanes, for instance, have computers, right? So you might imagine how it is very important that they properly test the software that they use on airplane computers. Can anyone tell me of a recent example of software related to aircraft that caused problems? I mean, that's a fairly recent one, right? Who wants to? You can speak. I mean, you go ahead if you'd like. 737 MAX. So someone said the 737 MAX. That's true. The 737 MAX is a Boeing airplane, 737. And the story with the 737 is that it couldn't compete with a newer version of Airbus's airplane, which is European. So they redesigned the plane with new flight characteristics. It made it unstable, basically. But they decided that they were going to fix that problem by adding some sensors and basically creating a program. And the program then would basically detect when the flight characteristics of the plane were making it unstable, and it would automatically stabilize the plane. Well, they never anticipated that if they had errors in their sensors, the whole thing could malfunction. And the pilots were not so aware of this software and what it was doing. And so basically they were just confused. They had no clue what was happening, it seems. And of course, unfortunately, that resulted in, 2 aircrafts that crashed with passengers. So obviously that led to deaths. And also Boeing is basically facing a serious problem now because all their aircraft, so-called 737 MAXs, have been grounded. So you can imagine what a huge impact that. Now, their problem was an engineering thing because their plane, like an aerospace thing, because their plane was made unstable by the changes that they made to the turbines. But just addressing it with software, it's in a way like a two-edged sword, right? It's almost like it's like an AI that took over, but it's an AI that's not very smart. And so the plane just thought, I need to stabilize the plane. And ultimately what it did is it actually caused the accidents. So anyway, so as a discussion, we want to talk about, here, oops, sorry. So, here I say, have you heard of other software bugs in the media, personal experience? So, we talked about the 737 MAX. How about other examples? Anyone have another example of something that maybe I haven't mentioned that you've heard about? Is there anything else? Nothing? No one has heard of anything else? I'm sure there's a lot of things. I can't think of anything recent right now. I believe they had an error in as I said, with Zoom, there was some kind of bug that caused disruptions yesterday. I don't know what's going on today, but certainly this thing is not working. It actually worked really well last semester, so I don't know what they did. But anyway, this was an opportunity for you guys to discuss anything you've heard about related to software problems. Usually when it comes to security, it's basically some vulnerability, probably a buffer overflow in some daemon, and they need to create a patch. And now, hopefully you know that a patch is nothing more than closing that code injection opportunity, right? So either by adding in the code some input validations or whatever. But usually it's a very simple fix. Finding the bugs is the hard part. Once you find them, usually fixing it is not very complex because it's ultimately input validation and things like that. Another place where this is important, another place where it's important to catch errors is in the specification, right? So the specification is the document that allows you to really in the life cycle of software, you should start with the specification, put all the details there, and then write the code. What's important about this semester is as part of the class software assurance, when you do your e-commerce site, you will also have to write some specifications. You'll have to kind of address in a document, a series of questions, and you'll have to provide a a description of the code. You're kind of reverse engineering it because I'm giving you the code. So you're going to have to kind of work your way back to the specification, but still we're going to do it just for completion. We're going to do the testing, the specification, and obviously, you know, getting the code to run completely. You have to do a demo. So the way that I like to do the demo is we take our time, we visit every aspect of your website, and as we visit every aspect of your website, I'm looking to try to break your code, right? So I'm looking, you know, I'm going to say, click on that, the one thing that you're avoiding in the entire presentation. I'm going to ask you to click on that and just to see if it breaks. Because remember that your program should meet both, you know, assurance of quality, but also of security. So definitely we'll do a lot of those things. So in conclusion, we're starting to get to the final point here of today's lecture. Kind of wrap up. A software bug occurs when at least one of these rules is true. The software does not do something that the specification says it should do, or the software does something that the specification says it should not do. So you did something outside of what you should have. The software does something that the specification does not mention. The software does not do something that the product specification does not mention but should. So, you know, you didn't think of it, and so on. And the software is difficult to understand, hard to use, slow. So you start to write. That's why people like having modular code to simplify the little pieces of the code so you can test it more in more detail. Okay, so this is kind of a summary then at this point. Basically, most of the bugs are not because, so here's some statistics. Most of the bugs in the program are not because of mistakes in the code. You know, a lot of the time the problem is related to, you know, specification, and these are the harder ones and the most expensive ones to deal with. So again, going back to the 737 MAX, right? You know, what will happen if a sensor fails? You know, what happens then? You know, how will the software react? And if that happens, you know, the simplest, so there were some pilots apparently that had the sensor failure, had this program come into action to try to stabilize the plane, which is actually causing it to crash. But the simple solution, apparently, if I remember correctly, was to disable the program. And so imagine something as simple as that, because at that point, a pilot, you know, they're very good, very proficient. So even if the plane starts to behave on, you know, they know how to fly a plane. But when they were fighting against this program, it's like they didn't really know what to do, right? So maybe in the specification, they should have had a safety, you know, approach that said, okay, whatever happens, disable the program if you have complications and so on, right? So that's, you know, that wasn't an error. You know, I'm sure the button was there. It's just that it wasn't, you know, they didn't think of it. So that usually happens when something is missing in the specification. Then the other errors come from, you know, errors in the design. Then finally the implementation of the code and other things as well. All right. What time do we have? Okay, 7:32. So I want to wrap up these slides so I don't have to come back to them. So the cost, and this again applies to the 737 MAX, right? The cost of fixing something, it becomes more expensive, or rather cheaper, the closer you are to the design stage. So for the 737 MAX, if they had found that error at the design stage, you know, all those planes would be flying, at least before the pandemic, right? They would have been flying every day. And now, because they found it so much later, it's costing them a fortune. I mean, people have talked about Boeing really, you know, being in serious financial trouble, for instance. Okay? So anyway, the relative cost of bugs found later cost more to fix. That kind of summarizes. Any questions about that, guys? You're very quiet today. So, you know, in conclusion, you can't really have bug-free software. You know, as software gets more features and support more platforms, it becomes increasingly difficult to make it bug-free. So you kind of have to live with that, but you have to mitigate as much as possible. And really, that's what, you know, one of the things that we will see later in the semester is that you kind of have to accept that you're going to have some bugs, but you want to mitigate some of them as much as possible. All right, and so, you know, then we'll talk about testing later in the semester. You know, this just sums up everything we've discussed. And then later on, we're going to talk about the software development process. So we'll talk about this later. We can skip that for now. All right, great. So that concludes the slides. Let me stop sharing here. All right, so that concludes the slides. Are there any questions about the slides so far?
Not right now, thank you.
All right, okay. All right, so the last thing I'm going to talk about today is the lab. Okay, the lab. So let me bring that up. So as you know, on Thursday, we will start our first lab. It's called a Set UID lab. So I have to give you some background on it. But let me open. Okay. All right, so this is the Set UID program vulnerability lab. And as I said, we talked about this in 372 Set UID. It was a mechanism in Linux. Anyone remember what Set UID does? Why do we have it? What's the purpose of it? What was Set UID? Nobody remember. Okay, so as homework, what I'm going to ask you to do is maybe Google or from your notes from 372, look up what happens when you want to change a password. And the password, as you know, passwords are stored in a file that is owned by root. But you as a regular user want to change your own password, right? So you're not going to call root and say, hey, root, can you change my password? You do it yourself. So that basically means that somehow you have to gain access to that root-owned file, okay? And that's where Set UID comes in. It's the mechanism that allows for you to do that. So I'm going to pick a couple of students on Thursday to kind of ask them that question, and then we're going to start from there and go over the lab assignment. This one, as I said, should be pretty straightforward. We're just going to look at certain things and really in preparation for the buffer overflow labs. Okay, so at this point, we have 3 minutes left, so I'm going to leave it open for a few questions. Otherwise, we're going to stop here for today. Again, welcome to ITS 450 Software Assurance. Hopefully, after the lecture today, you have at least an idea of what the course is going to be about. All right, so with that, I'll see you guys on Thursday. And as I said, I'll stay a couple of minutes if there's any questions. All right, have a good evening.
Bye, Professor.
Hello.
Thanks, Professor. Good night.
Oh, good night. Good night.